The National Electrical Code, or NEC, mandates ground fault circuit interrupter, or GFCI, protection for 110 volts receptacles in garages and unfinished basements, primarily because these locations often present a heightened risk of electrical shock. Firstly, these areas are frequently used for operating outdoor power tools and equipment. Secondly, they are more prone to moisture and water exposure. Thirdly, the grounding might be inadequate, thereby increasing the likelihood of electric shock. GFCIs operate by detecting even-minute imbalances in the current flow, which could indicate a ground fault. They are designed to trip rapidly, thus preventing electric shock. In contrast, the NEC generally does not mandate GFCI protection for 220 volts receptacles for a few key reasons. High-power appliances and devices, such as air conditioners, heaters, and certain power tools, often require 220 volts. The conventional design of GFCIs is geared towards protecting against ground faults, which are considered less likely to occur in 220 volt systems due to the inclusion of a dedicated neutral conductor. Implementing GFCIs on 220 volt circuits can present increased costs and complexity compared to doing so on 110 volt circuits. It is important to note that GFCI receptacles rated for 220 volts are not typically available commercially. The only practical method for providing GFCI protection to 220 volt circuits is through the use of a GFCI circuit breaker. GFCI breakers are available in both single-pole and double-pole configurations to accommodate different circuit requirements. In summary, the NEC GFCI requirements are tailored to address the specific electrical safety risks associated with different voltage levels and environments. While 110 volts outlets in damp or high-risk locations require GFCI receptacles, 220 volt circuits typically rely on GFCI breakers for ground fault protection.